Hello everyone, welcome to Data Discovery. At this video, we are going to see the concept related to empirical rule. So, what is this empirical rule? Why this empirical rule comes into the picture? And then, the most important in the standard normal distribution, we used to say that it follows 68, 95, 99.7 percentage rule. So, why this name comes into a picture and how the value, the 68 percentage or 95 percentage, how does it calculates? Everything that we are going to discuss at this video. So let's get started. So we know, like previous video from the standardization and the z score, the formula that we have seen, that it's around x minus mu by sigma, right? So by that, the by the normal distribution, whatever the data that you are having, if you will put your mu and sigma, you will be getting in the standard normal distribution as 0 and sigma is equal to 1. So this is how the plot, like mu plus sigma, mu plus 2 standard deviation, mu plus 3 standard deviation is nothing but 1 standard deviation away from the mean, 2 standard deviation away from the mean, and 3 standard deviation is away from the mean, right? So if you will put it over here, like in the place of x, okay, if you will put mu, it's nothing but mu minus mu by sigma, you will be getting a 0. So this is how you got. Second, mu plus sigma, in the place of x you put it as mu plus sigma minus mu you are having, and the standard deviation you will be getting as sigma by sigma is nothing but 1. So it's nothing but 1 standard deviation away from the mean. If you will put it over here, in the place of x you will put mu plus 2 sigma, then you will be getting as 2. So this is how that 1 standard deviation, 2 standard deviation, 3 standard deviation is away from the mean that we are getting through the z table, the z score value. Okay, now this 68, 95, 99.7, how does it comes? Okay, how the calculation actually happens, so that we are going to see it.
As we know that if the distribution follows the normal distribution, then if I will be dividing in between, if I will be dividing in between, then 50 percentage of the area consumed over here and 50 percentage, the rest 50 percentage of area consumed over here, right? So it's a part of the symmetry. Like if the distribution follows the normal distribution, then definitely the symmetry properties, it definitely follows, right? So by that, we are finding the value, the empirical rule. It's nothing but 68, 95, 99.7 percentage. How does it came? What is this percentage? Okay, this all we are calculating by using the Z table. Okay, Z table. I have already gone across it in my previous video itself. Okay, you may also get it, this type of the Z table. So what does the Z table tells it of? Okay, by doing the Z table, whenever we are finding the score, the percentage, what does it means? So this Z table doesn't find the probability. Z table doesn't find the probability. It doesn't means that like previously in every distribution, that whatever we are doing, the y-axis will be the probability, right? We used to write in the probability format like point 0.1, point 0.2. It means 2 percentage of the data covers over here. If point 0.3, 3 percentage of the data covers over here, like that we used to say. But the Z table doesn't find the probability. It's find area under the curve. It's find area under the curve. What will be the area that it's finding the, by using the Z table, that we are finding it. Whatever the curve contains from this to this, how much the area, what will be the area for it. So by using a Z table, we are getting it. Like previously also we have discussed around probability density function like PDF, by using area, like from 0 to whatever the lower limit and upper limit what we used to write, and f of x dx, so that we can get from area from this to this what will be the area that we can find it. So same thing happens over here. By using a Z table, we are not finding the probability, we are finding the area under the curve. Now we are going to construct the 68, 95, and 10.7. So by step we'll just move it. So as we know that this area contains the 50 percentage of the data, right? But my question is, what will be this area? One standard deviation is away from the mean. So what I will be doing, I will be calculating first this area. if I will be calculating this area, and if I will be subtracting this by 50, if I will be subtracting by 50 from this area, like from this area, if I will be subtract this area, then I will get this area, right? So same thing happens. If I will find this area and if I will subtract this area, then I will be getting this area. So this is nothing but one standard deviation away from the mean, positive side. So if I will get the positive side, and I can calculate the negative side also, same it will be there, because it's a normal distribution, it's a symmetry. The same area from one standard deviation plus positive also and negative also. So if I will add the first one standard deviation positive and one standard deviation negative, at my positive side and my negative side, whatever will be the area, that I will be getting it, right? I will be doing it practically so that the more concept will be clear. From this mu minus 3 standard deviation to mu, we are having 50 percentage of the data, right? But I will be calculating this one standard deviation is from the mean to area 1. Okay, what will be the percentage, that I will be finding it and I will be subtracting by 50. So this will be my answer. Okay, so let's find it by using a Z table. So it's nothing but one standard deviation. Finding this one standard deviation, positive side and negative side, I will be calculating from this area, from this whole area, I will be just calculating it. And then after I will be subtracting by 50. So let's find it. Yeah, that we need to find it. It will be around 1.0, that Z score, Z table, right? So 1.0 is nothing but 0.8413. It's nothing but I'll write over here 0.8413. It will be the my area. But though I am calculating in the percentage format, so we can take it like 84.13. So 84.13 minus 50 percentage. That is nothing but my this area, it's nothing but my 84.13 percentage it contains. Okay, it's nothing but as I have shown in the Z table, it calculates this area part, the shaded gray part, it calculates that area. Okay, so for if over here the value is 1, so what does it means, this from this to this whole shaded part, gray part, it contains around 84 percentage of the data. Okay, once we have came across it, so and then 50 percentage of the data from this to this to this, so I can calculate one standard deviation positive side. So that will be 84.13 percentage minus 50 percentage is nothing but 34.13 percentage. Okay. So 84.13 percentage minus 50 percentage is nothing but my 34.13 percentage. As I have said that I have calculated only the on positive side. So same thing happens on negative side also in this part also. So what I will be doing, I will be adding the same part, same value. Why same value? Because it's a normal distribution. If it follows normal distribution, then one standard deviation positive side or negative side, it will be equal. Deviation away from the mean. Positive side we got it as 34.13. Same thing happens with the negative side also. So we are writing the same value 34.13. By adding it, we are getting as 64.28. So one standard deviation is away from the mean. It's following this empirical rule. So we got it as 64.2 28 percentage. It's nothing but one standard deviation is away from the mean, positive and negative. Okay. Now let's calculate for two standard deviation away from the mean. The Z score formula, it's nothing but x minus mu minus standard deviation. So what will be my x? It's nothing but mu plus 2 standard deviation, right? So mu plus 2 standard deviation minus mu by sigma. It's nothing but mu cancel, 2 sigma sigma cancel, so the value will be 2. So if my value will be 2, what will be my Z score? Let's calculate by this value. Okay, as we got it over here, it's around 97 percentage, right? 97.72. Okay, we are taking this first column because as we have gone through it like 2.0, it's not 2.05 something like that, we got it. So for that 97.72. So over here, 97.72 percentage. It's nothing but two standard deviation is away from the mean. Okay. And then 3 standard deviation is away from the mean. 3 SD is nothing but z is equal to x minus mu by sigma. These are nothing but my formula. And then x is nothing but mu plus 3 standard deviation. So it's nothing but mu plus 3 standard deviation minus mu by sigma. It's nothing but mu cancel 3. So the value of 3 area. Yeah, 0.9987. It will be my area, but I will be calculating into percentage, so 99.87. So by that, you're getting that one standard deviation is away from the mean is around 64.28 percentage. Two standard deviation is away from the mean is around 97.72. Three standard deviation is away from the mean is 19. So it's approximately to our empirical rule, like 68, 95, 99.7 percentage rule. So it's approximately finding. So the z score by the z table, that whatever that we are doing it differs from each and every table. Like some table it will be approximate to 68 also, but some are it approximate. So it differs. It's how the empirical rule, the percentage that whatever we have written over here, it's been calculated. So for everything that we are doing it, the formula of the z score, the z table, each and everything happens because of reason. So I hope you got it. So what does it the empirical rule says that? The empirical rule says that the normal distribution, the ND, okay, is a well-known empirical rule, also called as a 68, 95, 99.7 percentage rule. So even this is also percentage. Okay. So in which it follows the 68, 95, 99.7 rule, which states that approximately 68 percentage of the data falls within one standard deviation of the mean. About 95 percentage of the data falls within a two standard deviation from the mean, and 99.7 percentage of the data falls within the three standard deviation is away from the mean. So how much standard deviation is away from the mean? That by using a empirical rule, a percentage, that we can get it. So usually to find the outliers, okay, whether this distribution contains the outliers or not, so what we will be doing, we will be calculating these values, one standard deviation, two standard deviation, what's the values, by using that we used to, by using a z table, by using a z score, we used to calculate it. And if it is away from three standard deviation, like this part, and if it is less than this part, like three standard deviation will be like this, so this part, so this we used to say that it's an outlier. So if any value is lying over here, so this is consumed as outlier. So outlier detection by using a mean standard deviation, it's one of the method to find it. It's not the only method. So for finding the outlier, there are various kind of the method, but this will be the one kind of the method that we will be following. I hope this video find it out so useful, as we have gone across this empirical rule, how this one standard deviation, two standard deviation, the value 68, 95, 99.7 is constructed, and the mu is equal to 0, sigma is equal to 1 by using a z score. We found it by using the formula. This type of the video related to data science, statistics, ML, I will be coming across this channel. Do like, share, and subscribe to the Data Discovery. Never miss out the updates. Thank you.